Hi guys, so today we're going to be doing direct joint and inverse variation, and you've seen it before. The book is just going to introduce to you an extra way or a new way of solving for them, but it is completely up to you whether you want to use the old way you've learned or this new way, okay? So here, direct variation is when it says y varies directly as x if there is some non-zero constant such that, and it's y equals kx. Okay? Joint variation, if you remember, it would be described as y varies jointly as x and z if there is some non-zero constant such that, so all it is y equals kxz. Right? And then inverse variation, if direct was this multiplying it, inverse is going to be where it's going to be dividing it. Okay. So before in the book, we've figured out what K is and figured out that pattern. But here, what it's going to introduce to you now is that when you have two pairs, right? So if Y1 is K and X1, and then you have another Y and an X, right? Here, what it means is that if we solved each of them for K, this would be Y1 over X1 equals K. And this one would be Y2 over X2 equals K. And since both of them represent K, if we're given an X and Y pair, we can find the missing one by setting them equal to each other, like this. And so that's why when you see your book solving it, it's going to be doing this. Okay? And I'll show you both ways when we get to our first example of direct variation. Okay? So joint variation would be the same thing, right? So then if it's y equals kxz, k is known as our constant of variation, right? So if we had one of the triples, so y1 equals k x1 z1, and the other one would be y2 equals k x2 z2, we can solve for k by dividing by the x1 z1, right? So same thing here, find y2 by dividing by the x2 z2, right? And if they're both equal to k, that means we can set it up as y1 over x1 z1 equals y2 over x2 z2, okay? If that's an easier way to find it, okay? So that would be the same thing here. If y1 equals k over x1 and y2 is k over x2, we can figure out k by multiplying x to both sides, right? So then x1 y1 equals k, multiply this, x2 y2 equals k, which means we can say x1 y1 equals x2 y2. And so what the book is going to do is it's going to instead use this, and this to solve it compared to how we did it before. Okay, so I'm going to show both the old way and this new way of solving it. And you can decide which way you prefer. Okay? So here it says if y varies directly as x, so that means y equals kx, okay? And y equals 12 when x equals 3, so y equals 12 when x equals negative 3. We want to find y when x equals 16. Okay, so here what you can probably notice is that, oh, y is 12, so x negative 3. Oh, that's because k is negative 4. Right? So same thing, if I then multiply this by negative 4, 16 times negative 4 is negative 64. So y equals negative 64. Right? That's the old way of solving it, right? If it's inverse, if it's directly, varies directly, right? It's because negative 3 times negative 4 is 12, so 16 times negative 4 will give me my y value. The new way that we're introducing it now is since their k's are equal, we can solve it this way where one of them is y1, x1, and the other one is y2, x2. Right? So in that case then, using what they've now introduced to us, we can do 12 divided by negative 3 equals my unknown y now over 16. Essentially, we're doing the same thing, right? And so now we're solving a proportion, so we're going to cross. So this becomes negative 3y equals 12 times 16. 12 times 16 is 192. Divide by 3 on negative 3 on both sides. 192 divided by negative 3. And this gives us negative 64. And we get the same answer. Okay, so it's just a different way of solving it. Right? So why don't you try CYP1 and then come check your answer. Okay, so you should have gotten R equals 30 whichever way you did it. If you got it right, you can move on. If not, here's your explanation. Right, so the old way is, 4 times what gives me negative 20, right? Because, okay, right, will give me R. That's negative 5. So 6 times negative 5 is 30. The new way to do it is R over S, negative 20 over 4 equals R over S, R over negative 6. Cross multiply, 4R equals 120, divide by 4 on both sides, R equals 30. Okay, so the next one is joint variation. So that is y equals kxz. Okay, so here we want to find y when x equals 8, z equals 3, if we knew before that 16 equals k, 2, and 5 here, right? So this is 16 equals k times 10. So divide by 10. This is 16/10, which is 8/5 equals k. So that I would enter it here, 8/5. Okay. And then 8/5 times 8 times 3. And then this gives me 38.4. Okay. So that is our old way of solving it. Okay. The new way of solving it would have us plug it in like this. So it would be our y unknown over x times z equals our y, this time we know it's 16, over x times z. Okay? Then we're cross multiplying. Right? So this is 10y equals 16 times 8 times 3. 16 times 8 times 3. 384. Right? Divide by 10 on both sides, y equals 38.4. Right? And you see we get the same thing. Okay? So why don't you try CYP2 and then come check your answer when you're done. Okay, I just did it in the new way, right? So here, if it says you should get R equals 28, if you got it, you can move on. If not, here's your explanation. So if R varies jointly as S and T, so that means R equals KST. To solve for K, we would divide by ST, so it's R over ST. That's what I did. R over ST, so R over 2 times 8 equals R over S times T, 70 over 10 times 4. Okay. Cross multiply, so R 10 4 is 40R. 2 times 8 times 70 is 1120. Divide both sides by 40, R equals 28. Okay. And so now this is example 3. So R varies inversely as T. So that means R equals K over T. Okay. Which means then that to get K by itself, it'd be RT. Right? So here, 18 times negative 3 equals R times negative 11. Okay? 18 times negative 3 is negative 54. This is negative 11R. divide by negative 11 on both sides. We get 54 over 11, right? Or this is 4 and 10/11ths is R. Okay, there you go. Okay, so why don't you try CYP3, and then once you're done, come check your answer. Okay, you should have gotten x equals 8, right? So since x equals k over y, okay, to get k by itself, you multiply y, so xy. So 24 times 4 equals x times 12. 24 times 4 is 96. Divide by 12 on both sides, you get x equals 8. Okay, so here is our last problem. Right? So the apparent length of an object is inversely proportional to one's distance from the object. Okay? So what that tells me is that the length is inversely proportional, so k over one's distance. Right? So Earth is about 93 million miles from the sun. Right? Mercury is about 36 million miles from the sun. We want to find how many times as large the diameter of the sun would appear on Mercury than on Earth. Right? Okay, so when it says inversely proportional, it just means that it's like this. The length varies proportional to that. So here, we're going to use our proportion. So we're going to do Earth is about 93 million miles. So 93 million. And then the diameter. We just want to know how it compares, right? So then it will be, we'll just use it as 1 unit for Earth. And then Mercury is about 36 million miles from the sun. Now here we want to know how many times larger it is. So we're going to make this as our unknown diameter. Right? And then we're going to cross multiply. Okay, so this will be 93D equals 36. Hold on. Sorry. Okay, we're going to actually scratch it. So if it varies inversely, so actually it's distance from Mercury to the apparent diameter from Earth. Apparent diameter from Earth. Okay? And then this would be distance from Earth over the apparent diameter from Mercury. Okay. This is to represent that inversely proportional part. Okay. So distance Mercury is 36 million miles, and then we're going to use the apparent diameter from Earth, 1 unit. Distance from Earth is 93, and then we want to find that diameter from Mercury. So this will be 36D equals 93 times 1. Right? And then when we do 93 divided by 36, we get approximately 2.58. So then, how many times as large the diameter of the sun would appear on Mercury than on Earth? It'd be 2.858 times. There you go. Okay. Okay, so then we're going to do the same thing for CYP4. So why don't you try it on your own and then come check your answer. Okay, you should have gotten 5.2 times as large, right? So this is how far Jupiter is from the sun over that 1 unit that we're going to use for the apparent diameter from Earth, equals distance from Earth from the previous problem we saw is 93 over apparent diameter, this time from Jupiter. Okay, cross multiply, 483.6D equals 93 times 1. Divide and you get 5.2. That's it for today. Have a great rest of the day. Bye, guys.